So today we're going to be having a look at domains and linear functions. So what is a domain? Well, a domain is a restriction on the values of x. So domain is all possible values of x. In a sense, it's kind of the limitations of the x variable. When I draw a regular linear function, so for example, I could draw something along the lines of this, you would notice that there are no limitations on it, right? You could put in the smallest value of x or the largest value of x. It doesn't matter. There's no restrictions. This is going off to infinity, and this is going off to negative infinity. So for this particular function, we would say that x is in the domain of the real numbers. You'll remember the real numbers from last lesson, meaning any possible number is perfectly valid. But we could put some restrictions on this. So for example, what if I didn't want x to be absolutely anywhere? So what if I wanted to put a limit on how long it went? Well, that's not terribly difficult. I can draw a restricted linear function. Now, the way I draw that is I can just draw the regular function, and then I just need to put some information on it. So you can see for this one here that the end point up here, that's 2, 4, and the starting point down here is negative 3, negative 3. Okay? So the domain for x is in between these two numbers. There's a few ways we can write this. The first way we can write this is saying that x is less than 2, because that's our bigger number, but is bigger than negative 3, because that's our smallest x number. Remember, we're only interested in x. But because these are solid points, that means that you're also allowed to be equal to negative 3 or 2. So we use the greater or less than or equal sign instead of the less than sign. Or the alternative way we can write that is we can say that x is in the range, using square brackets, negative 3 to 2. Okay? Meaning that you can be anywhere between these numbers, including edge cases. These two things are exactly the same thing, and they're different ways of writing the same domain. Let's have a look at another. So you can see on this function here, it's some kind of horizontal line. In this case, it's y is equal to 3. But you can see it's got 2 points here. One is negative 4, 3, and the other point over here is positive 3, positive 3. But you'll notice that they have different points. This one has a filled-in point, while this one has a hollow point. The hollow point means it's not inclusive, meaning you can be at 2.9, that's fine, but if you go to 3, we don't go to 3. Whereas this one down here, this negative 4 with the solid point, that means that it is inclusive. So the way we can write that is using interval notation with the less than signs. We can say that x is greater or equal than negative 4, but strictly less than 3. 2.9, fine. 2.99, fine. 2.999995, fine. But 3 is off limits, and everything above 3 is off limits. So we're putting restrictions on the x part of it. Let's have a look at one more. Alternatively, we can write this using this notation over here, the bracket interval notation. We can say x is in the set of negative 4 up to 3, square bracket on the left, smooth bracket on the right, meaning it's a solid point here, meaning it's inclusive of the 4 here, but on the far side, it's a hollow point, which is exactly the shape that it's making up there. Let's have a look at one more. So you can see in this final example that there's a restriction only on the lower bound. There's no upper bound restriction. You can go as far to the right as you like. You can see that the arrow is pointing off to the right, also down, negative gradient, but it's pointing off to the right, meaning that you can go as far positive as you like. However, there's a restriction on going to the left. You cannot go past this point here, and this point in particular would be negative 4, 4. So negative 4, 4 is our restriction, and because we're interested in the domain is only talking about the x-coordinate. So what we can say is that x has to be bigger than 4. Remember, it's non-inclusive, meaning it's a hollow point here, but there's no upper bound, so as long as it's less than infinity, that's fine. Now, we generally don't write less than infinity like that, so instead we just don't write anything. So that's how we can show that. Using interval notation, it looks like this. X is in the set of smooth bracket, because negative 4 is non-inclusive, it's a hollow point, up to infinity. And this is where we do write infinity. There's no upper bound. So, you'll notice whenever we use infinity, we always use a curved bracket. We never put square brackets with infinity. So that's a little bit on how to read domains on different functions. I know it's a little bit tricky. It gets easier the more we do it. I'll see you in the next one. Goodbye.